Hi everyone, my name is Renee, Program Officer with EcoSchools Canada. On behalf of EcoSchools, thank you for viewing this webinar as part of the 2023 EcoSummit. I'm pleased to introduce Dwight Peigan from Relay Education to present this webinar, Climate Change and Renewables. Dwight Peigan is Relay Education's workshop facilitator for Saskatchewan. He has a bachelor's degree in environmental studies from the First Nations University of Canada. In his free time, Dwight enjoys writing, fishing, hiking, and playing with his son, Colin. Dwight is passionate about nature and the outdoors. He strongly believes that education is the foundation of success and encourages youth to find classes that pique their interest and align with their passions and values. We would also like to acknowledge that the EcoSummit has been made possible with support from Natural Resources Canada. We're glad to have you join us for this presentation, and now I will pass it over to Dwight.
Thank you, Renee. So, my name is Dwight, and I work with Relay Education. So Relay is all about bringing renewable energy and related subjects into classrooms around Canada. We're a nonprofit organization, and we're very excited to do this workshop with you today. So today, the workshop we're going to be doing is called Climate Change and Renewables. So I will share my screen with you, and we're going to talk a little bit about climate change, the impact that climate change has on our planet, as well as other ways that we can kind of react to climate change. And without further ado, we'll go ahead and get started. So what is climate change? This is the first question that we're going to ask ourselves. And don't feel bad if you aren't quite sure how to answer this. There's a lot of different ways that you can probably answer this question. So the Government of Canada's definition of climate change is it's a long-term shift in weather conditions identified by changes in temperature, precipitation, winds, and other indicators. The two main causes of climate change are natural causes and human causes. So some examples of natural causes are things like volcanoes, solar radiation, and the revolution of the Earth around the sun. So those are all things that, for the most part, humans can't really control. So what you should take note of are human causes of climate change. So a word that defines human causes of climate change is anthropogenic. So these anthropogenic causes are about 50 times worse than the natural causes. Some prominent anthropogenic causes are the burning of fossil fuels and deforestation. Burning of fossil fuels is the leading cause of global warming, which is a major component of anthropogenic climate change. So what are climate change impacts? Impacts on people's lives, such as their income, homes, health, or well-being. There's impacts on species, habitats, ecosystems, and as well as effects on economics and infrastructure. Impacts can be positive or negative. So here are some examples by climate change. Food systems will be affected. If you shop at a grocery store, you may notice an increase in prices. Eventually, you may even see some of your favorite choices disappear altogether. Ecosystems will also be affected. As an example, California is constantly going through lots of forest fires that are modifying habitats for both people and animals. Canadians were affected by the last major California wildfires in recent years. So even in places that are far away from these forest fires, air quality is affected and smoke travels huge distances. Our infrastructure will be affected as well. Our infrastructure, for the most part, was designed 100 years ago, before climate change began adjusting precipitation patterns. We are seeing extreme precipitation events that are releasing a lot more water that our infrastructure could handle. This is how flooding occurs. So for instance, our storm drains and sewer systems were designed a century or more ago, and they weren't really designed to handle a lot of the different precipitation that we're starting to see in a lot of parts of the country. So responses to climate change can be placed in two categories, which are adaptation and mitigation. So climate adaptation protects people and places by making them less vulnerable to impacts of climate change. For example, to protect against sea level rise and increased flooding, communities might build seawalls or relocate buildings to higher ground. So that would be adaptation. Now, climate change mitigation, on the other hand, is action to limit climate change by reducing emissions of greenhouse gases or removing those gases from the atmosphere. So we're going to explore how climate change impacts will threaten our food supply, increase the number of heat waves and wildfires, cause the world's sea levels to rise, and affect our outdated infrastructure. And we are not currently experiencing this on a mass scale yet in Canada, but we will have people who need to migrate to different regions or countries due to climate change. So when we talk about people moving from place to place, we can think of maybe the fall or autumn season of 2021 in lots of areas within British Columbia. There was devastating flooding, which caused people to relocate to different parts of that province. Now, Kelowna is a city in British Columbia that is basically within British Columbia's interior. Now, the landscape in British Columbia can be very diverse and different depending on what region you're in. Kelowna actually sits in a very kind of dry part of the province. So which climate change impact would most affect or be highest priority in Kelowna? Would it be food shortages, heat waves, precipitation, or forest fires? So in reality, a lot of these might affect Kelowna, but the one we're probably looking at most is forest fires. So especially because Kelowna is naturally in what's known as a rain shadow, meaning rain is less likely to fall on this drier part of BC. We're particularly worried about instances of forest fires. Now, which climate change impact would most affect or be highest priority in Charlottetown, Prince Edward Island? So for Charlottetown, we're looking at sea level rise as being of most concern to us. And for Iqaluit in Nunavut, what climate change impact would most affect or be highest priority? And in this case, we're looking at temperature rising. Overall temperatures are rising pretty much everywhere in the world, but we really notice it by a huge amount when we're going to places like the Arctic. So which climate change impact would most affect or be highest priority in Toronto, Ontario? So in the case of Toronto, again, we're never going to be totally safe from things like heat waves, but in Toronto especially, as well as other large urban centers, precipitation is a climate change impact that we're really unprepared for. Like I mentioned, a lot of our infrastructure, especially when it comes to storm drains, sewer systems, they're not prepared for a lot of the heavy precipitation that we have seen in recent years. Again, a lot of our infrastructure, for the most part, was built a century or more ago. So we're going to go back briefly to responses to climate change. So it's not enough to adapt to the impacts of climate change, or else the impacts will continue to occur and cause more issues for the people and environment. We need to look at ways to mitigate climate change. So mitigation is ways we can limit and stop the impacts of climate change. For example, an increased use of renewable energy and new technologies like using electric cars, or changes in practices such as using public transit or buying less things. So mitigating climate change with renewable energy. One of the best ways to mitigate climate change is the use of renewable energy for electricity and by keeping fossil fuels in the ground. Renewable energy is a natural substance that replenishes quickly and it will never run out. So this, of course, excludes fossil fuels because they emit large amounts of greenhouse gases, which is a major anthropogenic contributor to climate change. In the year 2020, about 28% of the world's electricity was renewable. Renewable makes up about 67% of Canada's electricity production. And for the most part, that's mostly hydroelectricity. By 2040, it's estimated that around 45% of the world's electricity production will be renewable. So we're going to discuss three types of renewable energy: geothermal, wind, and solar energy. So we'll start off with the geothermal. Geothermal is the first energy that we're going to kind of look into today. And at this time, there's no current electricity being generated from geothermal in Canada, but projects are in development. So by looking at the map here, you can see that Western Canada is the best place for geothermal in Canada. So there's a potential for over 10,000 megawatts of electricity that we could harness from geothermal sources. Geothermal utilizes the heat from the Earth's core to turn a turbine. By looking at the diagram on the right, you can see that geothermal involves drilling pathways that are more than 1 kilometer deep into the Earth, and hot water or steam is pumped up, it's used to move a turbine on the surface, and then sent back into the Earth. Take a look at these two images. Both of these are considered geothermal systems in North America. But which one is true geothermal? The system on the right or the system on the left? So the system on the right is geothermal energy because it goes deep into the earth and utilizes the earth's core for heat. The system on the left is actually called geo-exchange and requires solar energy from the sun. The sun heats the ground. This does not involve the core of the earth. So while we take a look now at wind and solar power, we're going to be doing a couple of experiments. So the first experiment will involve wind power. And we're going to be testing how much electricity we can create using a wind turbine that has 2 blades, 3 blades, and 4 blades. So this is kind of the system I have set up here for this experiment. I have a model turbine, and even though this turbine is small, it's still capable of producing electricity. And we're going to be measuring that electricity with this device called a multimeter. So my multimeter is connected to my model turbine, and we're going to be testing 2 blades, 3 blades, and 4 blades. And I have a box fan here that we're going to turn on and aim it at the turbine and get the blade spinning. But what we really want to find out is what number of blades will produce the most electricity. Again, we're going to be looking at this multimeter and watching the numbers as they go high or low. So firstly, we're going to start with 2 blades. So I just need to make sure that you guys can get a good view of everything here. So I'm going to turn my camera this way. And I want to make sure you can see that turbine. So right now the multimeter is reading at 0, but you can see if I spin my model turbine, the number goes up. So right now there's two blades. We're going to turn this fan on, and then we're going to watch the multimeter and see how high the number gets with 2 blades. Okay, so I'm going to start the fan now, and let's watch the multimeter. Okay, so we're basically looking for the highest number, and I've seen it get as high as 0.65. So this multimeter is reading electricity in volts. So now what I want to do is I want to attach a 3rd blade. And we'll see if the 3rd blade causes the turbine to create more or less electricity. So as you can see now, we have 3 blades instead of 2. And once again, we're going to watch our multimeter And do you think that 3 blades will create more or less electricity? So with 2 blades, we got 0.65. Let's start the wind and watch our multimeter. Okay, so with 3 blades, I seen it get as high as 0.93. Now, do you think 4 blades will make it go higher or lower? So 3 blades was a little bit higher than with 2 blades. Will 4 blades be even better? Okay, so as you can see, we now have 4 blades on our turbine. We're going to start the wind and we're going to watch this multimeter, okay? Okay, so thank you all for watching that multimeter. And once again, here are kind of the results that we came up with. So as you can see, one of these produced the most electricity, and it was 4 blades. So 4 blades outperformed 3 blades, it outperformed 2 blades, and we got about 1.32 volts just with this experiment we had here. So I'm gonna go back to the slideshow. And can anybody tell me why 4 blades seemed to outperform the other numbers of blades? So the answer in this case is surface area. So with 4 blades, you have a larger surface area, and that's basically more area for the wind to blow and spin the blades. And the faster the blades are spinning, the more electricity is going to be created. So we want our blades to move as fast as possible. Now, can anybody tell me why most wind turbines have 3 blades? So the reason most wind turbines have 3 blades, it has a lot to do with balance. So if your turbine only had 2 blades, it might wobble, especially in high wind speeds. And we want to create a safe structure. That's why 2 blades is never usually implemented. 4 blades too could be quite heavy. So 3 blades is kind of our magic number where the weight is distributed evenly and the turbine can spin safely. Now, like I mentioned, we want our turbines to spin as fast as possible because that's how we create the most electricity. But if a turbine is spinning too fast, it also can be dangerous. So when wind speeds reach about 65 kilometers per hour, we actually have brakes within the turbine, almost like brakes in a car, where we can apply the brakes and the spinning slows down a bit, and then that just creates a more safer structure. The good thing about wind power is you don't need a whole lot of wind. You only really need the wind to be blowing at about 7 to 13 kilometers per hour, which is a very light breeze. But as long as we have that amount of wind, our blades will start spinning and we can start creating electricity with that small amount of wind. So the next experiment that we're going to do involves solar panels. And with this solar panel experiment, we're going to be testing different colors of light. So we're going to be testing red, orange, yellow, and green. So here is basically the setup I have. I have a solar panel. We're going to connect it to the same multimeter, and we're going to do the same thing we did with the wind experiment. We're going to watch the numbers on the multimeter, and we're going to apply red light, orange, yellow, and green. And we're going to see which color actually produces the most electricity for us. So once again, I'm going to make sure that you can see this webcam really good. And we're going to take a look at this chart, and we're going to record what each color gives us in terms of volts of electricity. So let me just adjust this camera. Here is my solar panel. So allow me to connect it to the multimeter. And as you can see, even with this white light, we're generating about 4.54 volts. Okay, so once again, we're just going to watch the numbers on this multimeter, and we're going to pay attention to how many volts that we're getting for each color. So see if I can move the camera a little bit closer so that you can have a really good view of the numbers on that multimeter. Okay, so that should be good. We're going to start off with red. So red light is giving us about 4.40 volts. Now we'll try orange. Do you think orange will be better or worse? So here goes orange. Orange is giving us slightly more than red. Now, do you think yellow will be better or worse? So we'll try yellow now. And we're getting ever so slightly higher scores. So, well, it kind of went down there. I kind of moved the panel a little bit But now let's try green. Do you think green will be better or worse? Okay, so we tried 4 different colors, and here are our results. So which color gave us the most electricity? Yellow did. And which one gave us the least? Green did. Okay, so we'll talk a little bit about why yellow gave us the most. So sunlight is actually composed of all of these different colors. And when sunlight comes to the earth, all of these colors are actually present, but they're arriving at Earth in different wavelengths. So our current solar panel technology captures the light best in kind of the yellow and orange range. So for that reason, we've seen higher voltage when using the yellow and orange colors. But like I said, sunlight is composed of all of these colors, but typically we don't really notice all the different colors. So throughout most of the day, sunlight kind of appears as kind of just white light. But there are 2 times of day where we actually do see light in a more orangish kind of color. Can anyone tell me what 2 times of day that sunlight appears more orange? So sunrises and sunsets. So if you ever wake up for a sunrise or stay up late and watch a sunset, you'll notice that the light from the sun appears orange. So that's kind of the only times of day when our eyes can really pick up on all those different colors. And for the most part, sunlight appears as kind of white light. So depending on where you live, your area may be better suited to solar power or wind power. So because Canada is such a large and diverse country, different regions of Canada will be better suited to different types of renewable energy. So as you can see on the maps, Southern Ontario and the prairies are great locations for solar power, whereas coastal and mountainous areas have a strong and consistent pattern of wind that would be excellent for producing wind power. So one type of renewable energy isn't better, but sometimes an area will be better suited for either wind or solar because of its location. So no matter where you're living, you could probably benefit from both solar and wind, but depending on your area, one might be better than the other. So for instance, in Saskatchewan, we have a lot of new wind power that's coming up, but we also have a lot of new solar power as well. And especially in southwestern Saskatchewan, we're really better suited to solar panels. So we're really taking advantage of solar power in this part of the country as of lately, and a lot of new solar projects are coming up. So again, there's not one type of renewable energy that's better than the others. They all are great, and depending on where you live, you might be living in a place that's better suited for either solar or wind or geothermal. So human beings have caused climate change by burning fossil fuels. So this is anthropogenic climate change. And because it's occurring, we must adapt to potential impacts. We can reduce the severity of climate change by taking mitigation action. The best way to mitigate climate change is by using renewable energy to generate electricity and keeping fossil fuels in the ground as much as we can. Governments and industries are the main players in creating change. They must cut their emissions and change policies to focus on protection of the environment. You can make individual choices at home as well to help conserve energy. So that includes buying less things that will end up in the garbage, and create less waste. You can take part in community groups that support environmental activities. Remember, small actions can make a big difference. And it could be even things as little as turning the lights off when you're leaving a room, not wasting water or letting water run when you're not using it. Remember, all these small actions can make a difference. So thank you for having me today, and thanks for inviting Relay to do this workshop with you all. You can follow us on Instagram, Twitter, and Facebook. And if teachers or anyone else would like to book a workshop with us, please go to our website, www.relayeducation.com. We have a whole ton of workshops that are very, very fun for students and teachers as well. So please check out our website and see what kind of workshops we have. We're happy to offer all our diverse workshops to you. And yeah, it was a pleasure. Thanks for having me. And I hope to hear from you all again. Thank you.